In this video we have a look at the definition of a function and also some of the terminology that goes with functions, for example domain and range, independent and dependent variables, and we also look at mapping and how we use a vertical line test when we're checking for a function. The first definition we'll have a look at is a relation, and a relation is a set of ordered pairs. Now you can think of ordered pairs as being points on the graph, and we express those as pairs, for example 0, 1, 1, 3. You may also think of that as the x coordinate and y coordinate, so x would equal 0 for the first point and y would equal 1. A function is a relation in which no two ordered pairs have the same first number. So you can see in our relation there's a circle around the number 1 because that's been repeated. For a function to occur, that's not allowed to happen. So none of the first numbers in a set of ordered pairs are allowed to be repeated to be a function. Another set of definitions tied in with ordered pairs are the domain and range of a function. The domain of the function is a set of all the first numbers, and the range of the function is a set of all the second numbers. So we can see here that we've got the first numbers expressed in pink and the second numbers expressed in orange, and that matches the domain and range. So the domain is 0, 5, 1, negative 3, and the range is 1, 9, 4, 1. Now we can tidy that up a bit, and to tidy it up what we'll do is we'll express the numbers in order from smallest to largest, and we'll also remove any repeated numbers, so we don't need to express the number 1 twice when we're talking about the range. So far in our examples we've seen functions expressed as a set of ordered pairs with a finite number of points, but we can also have a function expressed as an infinite number of points. So we'll have a look at one now where we've got a function expressed in a graph, or more specifically a quadratic equation which has a parabolic graph. So given the equation y equals x squared minus 2x plus 2, we should be able to find some points on this graph, and we can do that by substituting in some random x values. Let's put x equals 1 into that equation, and if you do that for yourself you'll find out that the y value is equal to 1. So that means that we have the point 1, 1 on the graph. We can do that for other x values as well. For example, if x equals 3, we know that the y value that comes out of that equation is y equals 5. So that means the point 3, 5 is on the graph. But how do we determine a domain and range if there's an infinite number of points that are going to occur in our function? Well, what we can do is think about the x values that we can substitute into that equation. And we can see here along the orange x-axis that indicates that any x number is possible. You can substitute in anything that's negative, 0 or positive into that equation. There's no restrictions. But if we have a look at our graph, and we've indicated this with a pink arrow on the y-axis, there is a pink dot that represents the lowest point on the parabola. So on that parabola there are no y values that are underneath or lower than that pink dot, and that happens to occur at a y value of 1. So our domain is any x number, and the way we express that is we put in our curly brackets that the domain is equal to x such that x is any real number, and the range is equal to y. Again, the two dots mean such that the y values have to be greater than or equal to 1, and that's true because there are no points on the parabola where the y value is less than 1. Another pair of definitions which is tied in with domain and range are the independent and dependent variables. So the independent variable is the variable that represents the domain of the function, and dependent variable represents the range of the function. And the reason why they're called that is because the dependent variable depends upon the value of the independent variable. Consider the equation y equals 2x plus 1. X represents the independent variable, and we substitute into that equation and find out the y value based on the x value that we put into it. Another way we can show a function is through mapping. Let's have a look at the function y equals 2x minus 1. What we'll do next is we'll consider some x values and then see what y values occur when we substitute those into the equation. It might be wise to pause here, do the substitutions for yourself and see if you agree with the points that occur. So in no particular order, we can see that the points are 0, negative 1, 2, 3, 3, 5, and then negative 2, negative 5. So there's some of the ordered pairs on that line, and we can show them as a mapping. What we'll do first of all is take the numbers in orange, which are the x values or part of the domain, and put them into one group. We'll then take the y values, or numbers which are part of the range, and put them into a group adjacent to the one that we've just formed. And that will allow us then to create some mappings. We can see here in our mapping that -2 goes to -5. In other words, when we enter -2 into our equation, -5 is the y value that comes out. When we put in 0, we get -1. We can continue that mapping so that when x equals 2, we know that the y value that comes out is 3. And when x equals 3, the matching y value is equal to 5. So every single x value will have a matching y value. In this case, each one of the x values has a unique matching y value, and we call this a one-to-one function. Let's have a look at another case. We've got y equals x minus 1 all squared, and this ends up being a parabola. For this mapping, we're going to use x values of 0, 1, 2, and 3. So this would be a good place to pause to see if you agree with the y values that we get. So when x equals 0, we get the point 0, 1, and then we get 1, 0. For x equals 2, we get the point 2, 1, and then the final point is the point 3, 4. So we can see here our mapping shows the x values of 0, 1, 2, and 3, and the matching y values are 1, 0, and 4. We actually have one less. So 0 maps to 1, 1 to 0, 2 also maps onto 1, and 3 maps onto 4. So in this case, we have two x values going to one y value. This is said to be a many-to-one function. So that occurs when we have two or more x values going towards the same y value. Now let's consider another graph, very similar to what we had before, but it's undergone a translation and rotation. So we'll put some random points on the graph, and then what we'll do is we'll put them into our group so we can do a mapping. We can see that the x values are -1 and 1, so 1 has been repeated, and the y values are 1, -1, and 3. When we do the mapping, we can see that x equals -1 goes to 1, and when x equals 1, it goes towards -1 and also to 3. So this is called a one-to-many relation, and it's not a function. If we cast our mind back to the definition at the start of the video, we saw that if we had a set of points where the first number was repeated, or if the x number was repeated, then it's not a function. So a one-to-one relationship or a many-to-one relationship are both functions, but a one-to-many relationship is not a function. There is an easy test we can use on a graph to see if it is a function, and it's called a vertical line test. If we can draw a vertical line anywhere on the graph and it passes through two or more points, then that means that that relationship is not a function.